Saxon Advanced Mathematics Lesson 91. Our topic today is geometric progressions. I promised you this lesson a few lessons back when we talked about arithmetic progressions. I know that word looks like you should say arithmetic, but you don't say arithmetic progressions because the word has changed from a noun to an adjective. Whoa, English lesson. But let me remind you how arithmetic progressions work. Let's say we have one term, two terms, three terms, all the way up to n terms, some number, it doesn't matter. We start with what we call an A1, and we give that a name. That's called the initial value. And then we started adding, didn't we? We said A1 plus D. A1 plus 2D, and this D thing is called the common difference. And we know that we add it one more time with each additional term in the sequence, right? We can write a code for this so that if you want to find like the 45th term, you don't have to write them all out. It's the initial value plus the number of terms you're finding minus 1 times that common difference, right? And we can see that why that pattern makes sense because in the second term, you add 1D. In the third term, you add 2Ds. And we could keep going, right? In the fourth term, you'd add 3Ds. There's always a one number difference between those two. The number of terms is always higher than the number of common differences. And that's because in the first term, we don't add any common differences. So that's why that number is off. So that's why we subtract 1 from the number of terms, multiply that by the common difference, and that's how we get our final term. Now, that is how we do arithmetic progressions. Now, we're going to talk about these new beasts, the geometric progressions. We'll do the same thing. We'll look at the first term, the second term, the third term, and then the nth term. And that allows us to come up with a formula that we could use for any crazy high number of terms. All right, we start with A1. Oh, wait. Flashbacks. Remix. It's the initial value, just like before. But this time, we multiply A1 times something called R. And then the third term would be A1 times R times another R. Or we could say A1R squared. Oh, see what we're doing here? We're multiplying instead of adding. So geometric progressions imply multiplication, whereas arithmetic progressions imply adding or subtracting, right? Adding a negative number. So now we're multiplying. And the little formula that we can use for any formula we want is you take A1 and you multiply it by R raised to the power of the number of terms minus 1. This is AR. We could put a 1 here, right? So when it was the second term, we multiplied it by R to the first power. When it was the third term, we multiplied it to the second power. So we have that same kind of lagging thing here. And that's why this formula tells us to raise R, the common, oh, I didn't tell you that. This is called the common ratio. That's the name of R. Okay? We raise the common ratio to an exponent that is the number of terms minus 1. And again, that's just because we have this lag, because the first term does not have any common ratio part to it. Okay, so it's same but different. You know what I'm saying? So what we're going to do is try a few problems using this common ratio business. All right, I'm going to copy this to the top of the next page. The nth term equals the initial value times the common ratio raised to a power that is 1 less than the number of the term you're trying to find. Okay. Example 91.1. There are, I think, 5. Let me check. 4. I feel like you should always know how many examples there are because it kind of allows you to parcel out your brain energy, right? If we have more problems, don't use it all up early. Find the 5th term in a geometric sequence whose first term is -2. So I can write initial value equals -2, and whose common ratio is -3. Okay? I could write this as 5 equals n, right? Because that's the number of terms. All right, so now we've got all we need. We're going to plug that in. So our value is going to be -2 times -3 to the n minus 1 power. So that will be, I'll just write it out as 5 minus 1 so you can see exactly how I got that. All right, I like it. That equals 4. So this would be -2 times, let's see, what's 3 to the 4th power? -3 times -3 is 9. So then 9 times 9, that would be 81. So that means that the 5th term would be -162. All right, that seems reasonable, right? Not so bad. Of course, John's gonna take us deeper into the woods. That wasn't hard enough for John. 91.2. Find 3 geometric means between 4 and 64. Now let's review what that means. Means, quote unquote, are the numbers in a sequence that are not the beginning or the end. They're in the middle. So what we know is that this must be a 5-part sequence. This is the beginning, this is the end. So I'm gonna write 1, 2, 3, 4, 5. I know this one's 4, and I know that this one is 64. So I know that a to the 1 equals 4, and I know that a to the 5th one equals 64, right? And I know that a to the 5th would also equal, using this, it would be a1 times r to the, it's the 5th term, so it would be the 4th power, right? So I can put these two together, and I can say, and I also know that a1 equals 4, right? So I can put a 4 in here. I'm going to substitute all of these together. A to the 5th is 64 equals a to the 1 is 4 times r to the 4th. I don't know what r is. That's a big part of what we're trying to find out, right? But this makes sense to me. So what I can do first is just divide that 4 away. And I will get that 16 equals r to the 4th. And that's pretty cool because I know that I can find the 4th root of 16. I'm going to write them in opposite order. This simplifies to r equals, the 4th root of 16 is 2, but hold the bus, it could be positive or negative too, couldn't it? Arithmetic means can be quite tricky because if our common ratio is root, we can get a positive or a negative common ratio, and that means we're actually talking about two different sets of possible means, okay? So what we're going to do is sort out two sets of solutions here. I'm going to copy this information to the top of the next page. We know that A1 equals 4 and R equals plus or minus 2. Right? So, if R equals positive 2, we'll have one set of numbers. If R equals negative 2, we'll have a second set of numbers. The second term, we know the first term is 4. And let's see, we also know that A to the 5th is 64, right? We'll put that there. If it's the second term, that means it's A1 times just plain R, right? And that would equal 4 times positive 2, and that's 8. If R is negative 2 in the second term, it's still A1 times R. It would be 4 times negative 2, and that would equal negative 8. All right, third term, that would be A1 times R squared, right? So that would be 4 times 4, which is 16. And over here, it's also A times R squared. But look, this time, when we square this R, it's going to become positive 4. So these are both positive. See what's happening? If we have an odd number of roots, we will have different answers. If we have an even number of roots, they'll be the same because the minus signs get squared. Oh, that's kind of weird, isn't it? Now let's do the fourth term. This is A1 times R cubed. So again, it's 4. R cubed, 2 times 2 is 4, times 2 is 8. So this would be 32. Oh, look, I forgot the equal sign. And now over here, it's 4. But when we cube, just a second, I want to make my columns clearer. When we cube minus 2, we get minus 8. And now look, we're back in negative 10. So now I've done my calculations for the second, third, and fourth terms, which are the means. Now let's go ahead and write out our sequences. There's our beginning. There's our last. So the sequence would be 4, 8, 16, 32, 64. That is one possible sequence. And what John does sometimes is he shows all 5 terms, but then he puts underlines under the ones we figured out. That's cool. And now we'll write this other possible sequence. Again, A1 would be 4, but then it would be minus 8, positive 16, minus 32, positive 64. So this is the other possible sequence. The other 3 geometric means that could lie between positive 4 and positive 64. That's what makes geometric progressions a little trickier, is if you have a negative sign on your common ratio, you'll get this flip-flopping back and forth pattern depending on whether there are an odd number of common ratios or an even number. Even numbers cancel out the negatives and make it positive. Odd numbered common ratios leave you with a minus, okay? Oh, that's just all clear as mud, isn't it? 91.3. I feel like I need a fresh page. You know, I do encourage you to give yourself lots of fresh pages in your homework, especially if a problem has given you a little drama. Turn the page, get away from it. Okay, 91.3. Find 2 geometric means between 2 and 1/4. Okay, so this time it says 2 geometric means, so that means 2 in the middle. That means there must be 4 terms. The first one is 2. The last one is 1/4. Okay? We know that this is A1. We know that this is A4. We know that A4 equals A1 times R to the one number less than that, third. So now we're going to do the same thing where we're going to set up an equation that we can solve and solve it for R to the third, all right? We've got a value for this, it's 1/4. We've got a value for this, it's 2. So we can write 1/4 equals 2 times R cubed. All right, that seems reasonable, right? So, we have to divide by 2, but I don't want to divide by 2 because that's going to make a mess over here. So instead I'm going to multiply it by 1/2. Same difference, but it just makes the multiplication a little more straightforward. This and this cancel, and then I get R to the third power equals 1/8. I'm switching sides just because that feels better to me. Now we need, you know what we need? We need to cube root this, right? This tells me that R equals, let's see, the cube root of 1 is 1. The cube root of 8 is 2. But we have to ask ourselves, is it plus or minus? Well, the third, the number that we took the root of, there, that's what I was trying to say. The number that we took the root of was positive. So that means the root has to be positive. If this was a negative, then this would be a negative. But this is a positive, so this is right. So we don't have plus or minus options in this one. So now we are ready to calculate. We know that this is A1 times R, and this is A1 times R squared. Right? These are a little simpler. Last time I made a chart down here because the calculations were kind of crazy. But this time I'll just do, this is 2 times 1/2, so this equals 1. And this is 2 times 1/2 times 1/2. I can write it out like that if I want, right? And that is 2/4, and that is 1/2. Right? So if I want to write it as a sequence, I can write 2, 1, 1/2, 1/4. And I can put underlines under the ones that we solved for, right? The geometric means. Guess what? That's right. I mean, it's kind of fun, right? We could do more identities if you'd rather, but I think this is kind of cute, kind of fun. Okay, one more, and then we're done. Find the 3 geometric means between -16 and 1. So again, when he tells us how many means that we're supposed to be finding, we know that you add 2 more because you have to have a beginning number and an ending number. The means mean the one in the middle. So 3 geometric means 1, 2, 3, 4, 5. We are between -16 and -1. You always just put them in order. It says find 3 geometric means between -16 and -1. This feels backwards. Usually we have the smaller numbers here and they get bigger, but this is how this one works. Okay, we begin by figuring out what do we have and what do we need. Once again, this is A1, this is A4, and we know this is equal to A1 times R, one number less than that, 3. We've got the wait a minute, did I do this right? This is wrong. This should be the 5th. This should be the 4th. I was back in the last problem where we only had 2 means. But we have 3 means, so we have 5 terms, so that should be the 4th. Okay, so we know that A to the 5th, which is -1, Here, let me write it out as a formula first. A to the 5th equals A1 times R to the 4th. We can substitute in minus 1 for A to the 5th equals minus 16 times R to the 4th. We're just substituting those values into this expression, which I wrote again here so you could see how I lined them up. All right, we divide away the minus 16. And we get that 1 over 16, right, because the 2 minuses cancel, these cancel, equals R to the 4th. Now we're ready to take a square root of that. And we see that R equals, the 4th root of 1 is 1. The 4th root of 16 is 2, right? But guess what? It could be plus or minus because this number is positive, but we have an even number of roots. So minuses would end up positive here. So we have to consider both. Happy days, right? So let's do what we did last time. Let's create one set of possibilities for if R equals positive 1/2 and another set of possibilities if R equals negative 1/2. These will be our two columns. And we know that the second term that we're trying to find will be A1 to the R. I'm sorry, I didn't say that right. A1 times R. So that would be A1 is minus 16 times 1/2 would be minus 8. Third term will be A1 times R squared, which will be minus 16 times, that squared is 1 over 4. That equals minus 4. Fourth term, working around the hole in the page, A1 R third minus 16 times, okay, what's this to the third power? 1/2 times 1/2 times 1/2, 1/8. And this equals minus 2. So because our starting value is negative, even with a positive R value, we got all negative answers. Because negative times a positive, well, that makes sense, right? All right, now let's do the same thing with our negative value for it. So I'm using this formula over here. A is still minus 16. And we multiply it by minus 1/2. That equals positive 8. Okay? A1 minus 16 times R squared. Okay, well, when we square this, it's going to go positive, right? It'll be 1/4. And this gives me minus 4. Okay. Here it's minus 16 times the third power of this. It's going to be 1/8, but it's going to be negative, right? There will be 1, 2, 3 minus signs. So that leaves us with a minus sign. So that's minus 1 over 8. And that equals positive 2. So this one's all negatives. This one jumps back and forth. Weird, right? So let's write them up here. Where do I have space? I'm going to write my answers way up here. Our first sequence would be minus 16, and then these, minus 8, minus 4, minus 2, minus 1. And we would underline the ones that we figured out, the means, right? The 3 geometric means. And then the other option with the R of negative 2, we still start with minus 16, but then we would have positive 8, negative 4, positive 2, and negative 1. So, like I said before, that's kind of the tricky thing about the geometric means is that the minus signs can jump around a lot more, and we can get different R values, different common ratios that allow us to get 2 sets of answers. So live with that if you dare. Okay, that's all for lesson 91. I hope you enjoyed it. I know I did. Thank you, goodbye.